Good day, folks. I hope this is working like the same time. A little bit of log on my progress with this, and I'm just gonna wait a moment to see. Yes, it is. There I am. It takes a moment for me to see myself in the studio, believe it or not. So I'm never sure if it's working. So I'm just gonna wait a few moments for people to log in. I know it's random, and it always doesn't matter at the end because you could always view the video later. So I hope everyone is having a nice day. Today is a day of snow here. It had melted completely, but now it's starting again. I can see out my window. I guess it's one of those stay-in days. As I was experimenting with some AC and DC frequency mixing and things like that, and I presented a crude circuit just on the spot here. I was trying to, unfortunately, I didn't have a diagram to show you folks because I was just doing it on the fly, soldering something together here. So I tried drawing it on my board and I wasn't a very good drawer. So I took the time here to try and actually draw it properly. So I will show you that in a moment. And I did some testing. I didn't take videos of this because I didn't really notice anything that fascinated. It pretty well did what I thought it did. And all of you can basically replicate it if you don't believe me. There was basically nothing unusual there that I didn't expect. So you can try it for yourself. At some point, I'll probably make a video. But the thing is, I was so into it, and it was all a mess and everything. I'm like, oh, I'm not going to make a video when it's a schematic of like two parts, right? Again, if you want to prove me wrong, just build it yourself, I guess. So I will get to that in a moment, but I had presented a very primitive circuit in my last video for mixing AC and DC, non-efficient. Multiple people have their own ways of doing it. Don Smith in his own ways figured out how to modulate it for more efficiency. Other people let's say, Gérald Morin, even going more in history, Ed Gray and those people, they all had their ways. Because the thing is, and I will get to that in a moment here, just building up the case here, what happens is, and some people have pointed this out, in a closed loop circuit, let's say we're running a traditional closed loop circuit, and you try and mix, let's say, the AC and DC, what usually happens, and when I say usually, in the traditional closed loop is whichever one that has the higher power essentially creates a gap for the other one to. So it's not that easy for the two to simultaneously exist on the same loop without some kind of fancy interaction to indirectly have those two systems interacting, okay? So this is where yesterday I figured, well, you know what? My idea was I'll put a capacitor on there and I'll switch it primitively with a 100 volt gas discharge tube here I had laying around. It'll be very primitive, but it'll give me that oscillation, that break in the circuit for a moment where essentially the capacitor through the displacement current, it's very inefficient essentially, but what I'm trying to do is create that condition for a moment where the capacitor sees both systems, which makes it charge fast essentially. So the gas discharge tube can do its thing and switch the capacitor through an external load. So it's not exactly the same traditional kind of electricity you would get on the output of this. So this is why I think people like even Moray like sticking with what I like to call analog circuits, like analog light bulbs, because it works very much like a tube. It has a heating element, and once the heater turns on, it takes much less to keep it going if you can. And of course, it's much more currents, the variation, the fluctuations, the light bulb will have no problem with that. So essentially, I believe that's why they like calling these kind of things suitable for inductive loads, essentially old-fashioned element, inductive heaters, so you can generate very analog primitive circuits will enjoy this kind of electricity But even trying to run like an LED light bulb, a switching power supply, anything that has computers, integrated circuits, switching, it'll cause havoc. It doesn't work. You know, I even tried this circuit yesterday on a LED light bulb, which has their own oscillators, and once in a while it would flash, and that's it. It wouldn't stay running. But surprise, surprise, when I hooked up my analog, I call it analog, but it's in this incandescent light bulbs here, it had no problem with minimal flicker. And this is a 100-watt bulb, okay? And it ran, I mean, I didn't have professional measuring equipment or anything, but to my eyes, let's say, it seemed like it was near what the brightness would be. Now, considering what I was putting into it, because I had limited the AC at 110 40 mA, and I had a 12-volt power supply that was relatively low power. And sure enough, you know, I tried running it off the power supply on its own, and the light barely dimmed, right? But when I turned everything on, everything was nice. But the problem I was having is the spark gap got incredibly hot within seconds. So all the energy was being concentrated, I guess, through the spark gap. And now that there's a few people, I will show you the circuit here. So this is the more completed version of what I was doing. And I will tell you, highly inefficient, but it does something interesting. So we start here, what I was doing, my DC feeds like essentially backwards transformer. So we're feeding our current on the low DC side and the equivalent of high voltage. I wanted to keep it safe here. So I kept this at 110 volts AC, but limited with a capacitive power supply to 40 mA. So there was my high voltage that the light, the lamp wants to run. And here's my high current at DC. So essentially, the circuit tries to mix both together here, and this capacitor here charges for a brief moment interacting with both fields. You see, you can't close loop this because of what I said before. One will block the flow from the other. But if you keep resetting it, the capacitor for a moment sees both and it recharges much faster. Now, one thing I noticed with the circuit was while it was running, none of these components were getting hot here at all. The rectifier kept running very cool. My external power supply, I kept putting my hand on it, very cool. All the components here, very cool. The capacitor here, very cool. Even the reactive capacitor on the AC limiting the current, very cool. But for some reason, the spark gap was like burning, you could smell it. But that 100-watt light bulb here from the pulse. So what happens is you end up having an output of a high current, high voltage pulsed output is essentially what happens here. It's a pulsed DC output. So this is very inefficient, but as inefficient as it is, it did do some interesting and pretty good results. But like I said, hardly anything will run off of this kind of power here. So this concludes me to say that for this to work properly, you'd probably have to at least, you see, the issue here is having both interacting at the same time. So in a closed loop environment, one will always want to like oppose the other without any fancy mechanism here. But at high voltages, things change, you see. If we were to use, let's say, 3000 volts 40 mA instead on the input here, some people already notice there's additional interactions such as skin effect that comes into play, where the high voltage will carry the current along the wire and pretty well ignore semiconductors along its path, many of them anyways. So what I'm getting at it, here's a way at high voltage to bypass the limitation where one would stop the other. You use the skin effect to transfer the high voltage to that capacitor while it's interacting with the high current, low voltage DC. So this way here, much more efficient way, and that's probably what Don Smith was doing in some of his big reason why, you know, and the ion valve being part of that as well at high voltage to sustain this loop here. So I just thought I'd put it out there. I never really experimented much with this until a few days ago. So I made some pretty, what I think are sound conclusions already, leading me into the right direction and understanding why these iconic figures were doing what it is they were doing. Because you see, folks, sometimes it's one thing to have an explanation in an old pattern or something, but without experimenting with it and understanding why it is they're doing what they're doing, you see, I had an idea, why not just do it at 100 volts? It'd be like scaled down, but shouldn't I get the same results? Partially I did, but I also learned something along the way why it is they were using high voltages for this, because there are traditional limitations with this kind of a circuit here. So just putting it out there, folks, just for the information, it might be helpful to those who are experimenting with this kind of thing. So yeah, particle accelerators, I don't have much experience with that other than, shooting high voltages in X-ray tubes, which I don't recommend, by the way, because it could be dangerous, But I did that. But that's about as far as I ever took it, messing around with soft X-rays with old vacuum tubes. Gas plasma tube, yeah, that could work. Maybe use maybe experiment. Sounds silly, but you might be able to experiment with some of these lamps here, or any other kind of. I was able to convert scalar waves with one of these. Very old project. I couldn't find the video, unfortunately. It's from like 4 places ago, so that's how long ago it was. But no, honestly, I don't want to make anything up here. Very little progress in that direction myself. Not to say the field isn't interesting. It's just there's so much to explore out there, right? I wish I could do it all, but I just can't. So yeah, that's pretty well what I wanted to cover here. And how long? I haven't been very long, so just a few minutes. I should have actually just made this into a regular video, but I had the laptop here, so which I use for going live, so I figured, just go on. Movies, nice. See, that's something else I don't do. I don't watch movies. I don't watch much television. I watch the news. That's it, actually. I don't know celebrities. I don't follow any of that. Um, my goodness, what was the last movie I watched? I'm trying to remember now. The last movie I actually watched. That's quite a question. Now that I'm on the topic, I'm trying to think, because I do watch very rarely, but let's see now. My goodness. The Day After Tomorrow, I think, was the last movie I watched. The Day After Tomorrow, when it came out. You love the way the stream. Thanks for that. I just try my best, It's not much of a set, It's just it is what it is. I found a good spot to place my laptop, so it gets the angle just right. So, don't mess with it if it works, they say, right? So, yeah, I wish I had more to say today. I just wanted to clarify that because some people were interested in that circuit, and I'm so sorry, folks. Yesterday, I pretty well butchered the drawing live on the spot, so I actually took a ruler here to try and help me draw it for this video here, but unfortunately, the ruler was too big to fit most of this square here, so I still ended up doing most of it by hand, but hey, I guess I'm going to give myself an A plus sticker for effort. I got to start somewhere. Yeah, for sure. The movies, the science fiction stuff can be quite thrilling. Um, when I was much younger, I was into the Star Trek stuff because futuristic quantum physics and all of that. Liked a lot of that. Started with Star Trek Voyager, then got into all of them, and then once you've watched them 2, 3 times, you get kind of bored with it. But yeah, I mean, when I was much younger, it was pretty good stuff. 10 out of 10 for the effort. Yeah, I know. I just got to find a ruler that's a little smaller next time, and I'll be all set. My lines are almost straight, folks. Getting there, getting there, one step at a time. So, with that said, I'm going to wrap it up. It was just a quick hello to everyone, and I just wanted to clear that up. And I hope you all enjoy your day. And again, thank you all for spending some time with me, and have yourselves a great day.